Hi, Charan. How are you?
Fine, sir.
Right. Right. Just let's wait for a minute. Okay. Location will not. Okay. Let's start now. So we were discussing about the circular motion, isn't it? Right. Right. Okay. So let's continue now. Okay. Now. So circular motion, many questions we have discussed, isn't it? Like how do we calculate the force towards center, isn't it? Time period of the satellite motion. Please tell me, clear up to this? What we have discussed in the previous class? Please tell me, clear? Tell me, is this clear up to what we have discussed? Hello? Hello?
Yes, sir.
Right. Okay. So let's continue with that. Okay. Now, the circular motion, we have discussed that whenever a particle does the circular motion, what happens? There is a force requirement towards the center, isn't it? And that net force towards center will come how much? It will come mv square by r. Okay. And net force towards center is also called as the centripetal force, right? So which force provided the centripetal force? So out of any real forces means what? Normal is a real force, gravity is a real force, isn't it? Tension is a real force. So depending on how the object is connected or what are the forces acting on the object, right? What will be the situation? So we will calculate what are the net force acting on the particle and its component towards center, right? Sometimes the force will be not exactly towards center, right? So in those situations, what we will do, we will take the component of those forces towards the center, and the net force towards center should be equal to what? It should be equal to mv square by r if velocity is given in the given of the particle, or m omega square r if angular velocity is given in the given for the particle. Okay, so let's discuss another example. In this example, it is called the conical pendulum. Okay, sometime that question will be given as what? The conical pendulum, and sometimes this is just an example. Okay, so conical pendulum means what? In this case, there is a particle connected with what? A string. Okay, something like this. And particle is like this. It is how connected. And this string is making what? Some theta angle with vertical. And the motion of this particle is what? The motion of this particle is in the horizontal plane. Understood? Something like this. This is a kind of pendulum, and it's a moving in what? In a horizontal plane. Okay. So now in this question they are asking, and let's say the length of the pendulum is something else, right? So they are asking what is the velocity of the pendulum? Okay. What is the velocity of the pendulum? What is the time period of this conical pendulum motion? Understood? Okay, so how do we calculate it? The first thing we will start is with the free body diagram. So if you draw the free body diagram, what forces you will find out? There will be a tension force acting and there will be an mg acting, isn't it? Tell me. These are the two forces acting on the particle, understood? And now if I say this angle is theta, so this vertical opposite alternate angle, that is also going to be theta. Up in circular motion, we should take the component. Which component is going to be mv square by r? So the component of force which is towards the center, that will be equal to mv square by r. So if you take the component, this component will come t cos theta, and there is going to be another component which is going to be t sine theta. So from equilibrium, we can say that the t cos theta is going to balanced by mg force, right? Because that is not towards the center, isn't it? Which force is towards the center? So this t sine theta is what? Towards the center. So t sine theta, what I should do it? I should write it as what? mv square by r. Please tell me, clear this one? This is the t sine theta, which we can write it as what? mv square by r. Now, if you look at this diagram, can you tell me what is going to be the radius of circular path? So you see this length of the pendulum is given L and this angle is given theta. So this radius can be write it. Radius is going to be L sine theta. Check it. Radius what we are getting? L sine theta we are getting. Understood? So if you want to calculate the linear velocity of this or tangential velocity of the particle, you will use it mv squared by r. And if you want to write it the angular velocity, then you should write it m omega square r. Now divide equation 2 and 1. If you divide equation 2 and 1, you will find out what you are getting. If you divide 1 and 2 or 2 and 1, so you are getting sine theta by cos theta, which is the tan theta. And if you divide it, m and m will get cancelled. This is v square by rg coming to us. So what is the velocity of this path, this particle? The velocity of this particle is rg into tan theta we have. So under root of, and what is the radius we have calculated? The radius we have calculated as L sine theta into z into what? Tan theta. Tan theta is also equal to sine theta by cos theta. Understood? So what is the velocity of the particle we are getting? The velocity we are getting under root of L into z sine square theta by cos theta. So this is what called the velocity of this conical pendulum. Understood? This is called the velocity of conical pendulum. If they ask what is the time period, so can I say time period means what? Time taken by the particle to complete one cycle. So in one cycle, how much distance it will travel? It will travel 2 pi r, and what velocity? V velocity. So again, you can write it 2 pi. In place of radius, you can write it as L sine theta. And in place of velocity, we can write it under root of L in place of velocity, what we can write it? Under root of Lg, right? Sine square theta is there. You can take it outside the root. It will become what? Sine theta. So whatever is inside the root, keep it. And sine square theta, if you cancel it out, it will get cancel out. So Lg sine square theta and cos theta in the numerator. So if you simplify it, this sine theta and the sine square theta will get cancelled out, isn't it? And further, you can cancel out root L and L also. So you are getting under root of 2 pi under root of L cos theta divided by C. That is the time period we got it. Understood? So, and other thing also they can ask you in this question, like what is the tension in the string, isn't it? Right or not? They can also ask you in this question, what is the tension in the string? So if you want to calculate the tension, you can directly get it from here. Tension, how much it will come? Tension mg by cos theta will come. Understood? So these are the things they are going to ask you in the question. So this is called a conical pendulum, but it is also what? It's a motion of the particle. And what we learn about this motion, that in the circular motion, what we are going to have, that net force which is acting towards center should be equal to mv square by r or m omega square r, depending on the question asks the velocity or they ask the angular velocity. Okay, understood? Please tell me, clear this one?
Yes, sir.
Please.
Yes, sir.
Right. Okay, let's discuss the next one. Okay, so understood these questions? These are all the questions based on what? The circular motion only, okay? Right? Clear? Now, sometime they will ask you a question like this. This is how a question is given, like this. A particle is attached with the help of what? The
Sir,
string. Yeah, tell me.
ఇప్పుడే జాయిన్ అయ్యా 8 o'clock స్టార్ట్
Yeah, tell me.
డిస్కౌడా
Hello. Okay, in this question, what they are asking? In this question, this is the string number 1 and this is the string number 2, okay? And it's
అరే
Mrinal,
అసలు
your
ఆడ
audio is
మాట్లాడేది కూడా అభి లగావుగా
Mrinal,
ఒక రౌండ్ ఓకే
Mrinal, your audio is on, okay?
సారీ సార్
Okay, please mute it, okay? Right? Okay, see this question, what is given to us, that angular velocity of the particle is how much given? Omega given. They are asking in the question, what is the tension in the string 1 and 2? Okay, find these two string will have different tension. Na? So find tension in the 1 and 2. Okay, string 1 and T1 and T2, please find how much it is coming. And you see this is given L and L. So that means actually it is given equilateral triangle, hai na? So that if you need the angle to solve this question further, you will be able to get it. Okay, can you tell me what will be the radius of the circular path of this particle? Is that going to be radius? Hai na? Because mv square, when you are going to write it, you will need the radius, and this all these three angles are 60 60. So this angle is how much? 30. So radius will become how much? Radius will become L cos 30 it will become. So please solve it and tell me how much is this coming. Omega is given in the question. Okay, omega is given in the question. Length of the string is L given to us. Both the string has the same length L. We have to calculate in the question what is the tension in the string number 1 and string number 2. Both the string, what are the tension we have, that is what we have to calculate it in this question. Okay, so please all of you try this one and tell me what is the answer coming. Try this one and tell me what is the answer coming to us. Draw the free body diagram first. Okay. Draw the free body diagram first and start with the free body diagram. Then take the component, right? Component which direction? Towards the center and perpendicular to that, right? And when you will take the component, then the net force which will come towards center, this is where the center of this particle going to lie. Na? This is the center of the circular path of the particle. Okay. So please take the component and then write what? Net force towards center equal to m omega square r. Let's check it. What is the net force towards center coming? And the other component will be what? Balancing each other, because in the other direction we have the equilibrium situation. Okay. So please tell me how much is this coming? Getting this one? Check it. See, if you draw the free body diagram, this string tension T1 will come, other string tension T2 will come, and this angle is 30 degree, this other angle is also 30 degree, and one more force is going to be, that is going to be mg. Now I'm going to take the component, okay, towards the center and perpendicular to this. If you see this component, how much it will come? T1 cos 30 will come. This other component, what it will come? T1 sin 30 will come. Same way, if you take the T2 component, what it will come? It will come T2 cos 30, and other component will come how much? T2 sin 30. Now let's write the equation. So T1 sin 30 will be balancing what? T2 sin 30 plus mg, right? That is the first equation. Second equation, towards center component. What is the towards center component? The towards center, the component we have T1 cos 30 and T2 cos 30. That is the net force we got it towards center. That we should write it as what? M omega square into R. Now just put the value. T1 cos 30 root 3 by 2. T2 cos 30 is root 3 by 2. M. What is omega? Omega is given in the question, omega square. And what is the radius? Radius is L cos 30. So L cos 30, if you put it here and simplify it, root 3 by 2, we got it cancelled from everywhere. So we are getting T1 plus T2 equal to what? M omega square L. That is my second equation. And if you look at the first equation, what are you getting? You're getting T1 sine 30 means 1 by 2 equal to T2 sine 30 means 1 by 2 plus mg. So actually the first equation what we have, T1 minus T2 equal to mg. Check it, the first equation. And I brought the T1 T2 one side. So I'm getting T1 minus T2 equal to, sorry, 2 mg. Now look at these two equations. One equation we are getting as T1 minus T2 equal to 2 mg, and other equation we are getting T1 plus T2 equal to m omega square L. Now we can simplify these two equations and get what? T1 and T2. So to simplify it, if I add both of them, then T2 T2 will get cancelled and T1 will come. The T1 will come how much? 2 mg plus m omega square L divided by 2. And if you subtract it, right, then T1 will get cancelled out. So we will have the T2 equal to what? M omega square L minus by V. Understand the value of T1 and which string has more tension, T1 or T2? Which string has more tension, T1 or T2? If you look at this expression, you are getting T1 is coming greater than T2. Understood?
Yes, sir.
Okay, right. So this is T1 and T2 value we have, right? So please see that whenever you are getting a question like that, always what we are doing, we are starting with the free body diagram, and from the free body diagram, what we're doing, we are taking the component, right? And the component of force. Sometimes we don't even need to take the component, right? In some of the question, you have seen it that the force was already acting towards the center. So if it is not needed, don't take the component. But if it is needed, then take the component, right? And make the net force equal to what? Which is towards center. Equal to how much? mv square by r or m omega square r. Now, Abhi, till now what we have seen, all these questions where the omega has been kept constant. Now, the next is the vertical circular motion. So, vertical circular motion is what? Actually an example of non-uniform circular motion. Okay, so let me discuss about the vertical circular motion. And in the vertical circular motion, we will need to apply work energy theorem also. Okay, although it is the next chapter for us, work energy power, where we will discuss work energy theorem in detail. But here also we need to apply in the vertical circular motion. So a little bit I will tell you about the work energy theorem. Okay. So non-uniform circular motion. That's why I'm going to discuss few of the question of vertical circular motion. Okay, and some more question of vertical circular motion I will discuss with you when we will go to the work energy chapter. Okay, work energy chapter also we need to learn about the vertical circular motion after work energy chapter. Okay, so in vertical circular motion, what happens? The motion of particle take place in which plane? It takes place in the vertical plane, something like this. A pendulum is there, it is attached with a fixed support, right? Now you see, if you give some velocity at this bottommost point, then what will happen? Then if I give enough velocity, right? If I don't give, let's say it is pendulum hanging like this. If I give some velocity, what will happen? It will go and again come back, na? But if I give enough velocity, then what will happen with this pendulum? It will go like this and it will start completing the circular motion, isn't it? So we need to provide a minimum velocity for that purpose. Okay. If I don't give that minimum velocity, what will happen? It won't be able to complete the circular motion. Okay. So what we should do it here, that we want to calculate what is the minimum requirement of that velocity. Okay. Clear? Here L is what? The length of pendulum. So here the minimum requirement is what? Under root of 5CL. Okay. It does not depend on the mass of the particle. Okay. Whatever the mass of the particle is there, but if I want what is the minimum requirement of velocity will come, then it will be always how much? Root 5CL. So if I ask you to tell me what is the velocity at the topmost point, velocity at topmost point, and keep in mind I have just provided the minimum requirement. Minimum requirement means how much is the velocity I have provided here at the bottommost point I just gave how much velocity? Under root of 5gl. Okay, so what is the velocity here? Something v. So to solve this one, we need to apply the work energy theorem. Let me mark these points. This point is A and this point is B. So we are going to apply work energy theorem. Okay. And work energy theorem can be applied between any 2 points. Okay. So between which 2 points? Between A and B. A velocity is known to me, B velocity I want to find out. So what actually I'm going to do, I'm going to take A as my initial point and B as the final point. I'm going to apply the work energy theorem between A and B. What is work energy theorem? Tell me, what is work energy theorem? All of you, are you aware about work energy theorem? Tell me. So as per work energy theorem, what we have, Work energy theorem does what? It relates the kinetic energy of the body and work done on the body. So, as per work energy theorem, change in kinetic energy means final kinetic energy minus initial kinetic energy. That is what? Change in kinetic energy. Change in kinetic energy is what? Work done by what? All the forces acting on the body. Okay. So, can you tell me what is the initial point is what? A is what our? A is our initial point. And B is the final kinetic energy. Can I say the K final minus K initial equal to work done? How many forces are doing the work? Actually, there are only two forces acting on the body. One is the tension, other one is the gravity. Divide the work done and kinetic energy. Okay. So just for finishing it, the vertical circular motion, we need this concept. So we are doing it, but please don't worry about this. Okay. So now tell me K final minus K initial. So K final, how much it will come? Half mv square will come. Isn't it? Final kinetic energy. Kinetic energy of any particle is what? Half into mass into v square minus half. Initial kinetic energy is how much? Root 5 cl square. Now tell me, what is the work done by tension? Can you tell me what will be the work done by tension? Work done by tension force on this particle? Can I say that it's going to be zero? Please tell me why. Because tension will be acting in this direction, isn't it? And displacement is happening along the tangent. Tell me, is the tension force is acting along the radial direction? Displacement is happening along the tangent. So force and displacement perpendicular. No work done. Let's say somewhere here. Again, this is the tension, this is the displacement. After some time, particle is here. This is the tension, this is the displacement, isn't it? So whenever a force is perpendicular to displacement, right? Whenever a force acting on the particle is perpendicular to displacement, work done by that force become zero. Okay, so that's why work done by tension, how much it will come? Zero it will come. Mine work done by gravity. Of gravity force is acting downward direction, and gravity is a conservative force. So conservative force work done only depends on initial and final point. And gravity acting downward and particle is actually moving upward. So that's why gravity work done here it will come negative. How much negative it will come? Mg into what is the height difference between the point A and B? That is 2L. That's the work done by gravity. Okay. Now let's simplify it. Okay. So if we simplify it, we are getting half mv minus half m into 5gl we have minus mg into 2l we have. Now just cancel out m by 2, m by 2, m. So here 2 it will become. So v is coming under root of what? CL. So if the minimum velocity is given or minimum requirement of velocity is given to the particle at bottommost point, which is root 5 gl, then at topmost point, what will happen? That velocity is going to be root gl, not zero velocity. Okay, please keep in mind, in the vertical circular motion, topmost point doesn't have the zero velocity. Actually, topmost point has what velocity? Under root of gl is the velocity at the topmost point. If you just give it minimum requirement, if you give it more than requirement, no problem, it will still do the circular motion, but that time what will be the velocity at topmost point? So again, using the work energy theorem, we have to calculate that. Can you tell me? Please tell me, do you understand this one or not? Little bit idea about the work energy theorem, all of you, please tell me.
Yes, sir.
Please tell me
Yes,
some
sir.
idea about the work energy theory. Please tell. Right. So next question I'm going to discuss with you. There I will use some more about this concept using the work energy theorem. Okay. Let's take one example here. In this example, what I'm going to do, let's say this particle has string of length L connected. Okay. And let me give the velocity here root 7gl. Can you tell me it will complete the circular motion or not? First of all, answer it. Is it going to complete the circular motion or not? Please tell me, did I give more than the requirement? Did I give the more than the requirement of velocity? Because the minimum requirement is root 5gl. And what velocity I have provided here? I have provided root 7gl. So it means this particle is going to complete the circular motion. Okay. And this point is A. This topmost point is what? Something B. So now in the question, I am asking two things. First one, find it velocity at topmost point. Velocity at what? Topmost point. Find it. How much is that? Second thing, tell me. Second thing, find it. Difference in tension. Difference in tension in the string. In the string at A and B. Understood the question? Means I am asking you what is TA minus TB? How much is that? Matlab TA magnitude and TB magnitude. Understood the question? What is the tension acting in the string at point A? Tension will be different at different point. Okay. So find the tension at A and tension at B. Okay. Third thing about this question, let's try to find it out. Let's say there is an intermediate point. Let's call this point as C. Okay. So in the third question, what you have to find ratio of tangential and it's a non-uniform circular motion. Na? Please tell me all of you. Vertical circular motion is a non-uniform circular motion. And in a non-uniform circular motion, we have both kind of acceleration like tangential as well as centripetal. The ratio of tangential and centripetal acceleration at point C means at point C, when the particle reaches the point C, what is the tangential acceleration of particle at point C? And what is the centripetal acceleration at point C? Please try it, these three things. Okay. Please tell me what is the answer of these three things coming to us. Here you are going to learn almost everything about the vertical motion question. Okay. Please tell me how much is this coming? Are you trying? Did you get the velocity at topmost point by applying the work energy theorem between A and B? Please tell me how much is this coming? Calculated? Chaliye, let me discuss with you. Okay, first part of the question, they ask what is the velocity at topmost point? Okay, so to calculate the first part, what I'm going to do, I'm going to apply the work energy theorem between what? Between A and B. Because I know the kinetic energy at A and I want to know the kinetic energy at B, and I will relate the A and B kinetic energy with the work done. Okay, so tell me kinetic energy at B. So what is the velocity at B? Let's say velocity at B is something V. So final kinetic energy will become half mv square. Initial kinetic energy will become half mass of the particle m root 7gl square. That is the change in kinetic energy of the particle when particle goes from A point to B point. And in the process, work will be done. Two forces are acting on the particle, tension and the gravity. That's it. These are the only two forces acting on the particle, isn't it? Again, same logic. Tension work done will be zero. Why? Because tension force is always perpendicular to displacement. So only the work will be coming because of the gravity. How much work done will come due to gravity? It will come minus because particle is going up and gravity is acting downward. Mz into again height difference between A and B is 2L. है ना? Point A and point B. Height difference is what? Diameter or 2L you can write it, right? We'll simplify that m by 2, m by 2, m. So here it will become 2. So we have V value, how much we have? Under root of, that is 7gl minus 4gl. So velocity we got it what? Root 3cl. Understood? This is the velocity at which point? At the point B. Now, they are asking what is the tension at A and tension at B. At the moment the question comes tension, that means we need to go for the Newton's law, because Newton's law tell me about the how to calculate the forces, isn't it? So at A, if they are asking, can you tell me what is the free body diagram at A? Can I say at A, tension will be acting like this and mg will be acting downward? Please tell me, when the particle is at point A, when the particle is at A, can I say tension is acting upward direction? है ना? This is the tension direction, this is the mg direction. And can you tell me out of TA and mg, which force is acting towards center? Is the tension is acting towards center? And what is its velocity here? The velocity is root 7gl. In a circular motion, what is the net force? Net force here acting is TA minus mg, and net force acting towards center should be equal to mv square by radius, isn't it? In a circular motion, net force acting towards the center. Here I don't need to take the component, isn't it? Why? Because already these forces are towards center, away from center. Already these forces are along the radial line, isn't it? That's why I should not take any component in this question. And we got our answer as tension at A is coming 7 mg plus mg, that is 8 mg. Okay. Now let's do the same thing for the point B. If you look at the point B, can you see at point B what you are finding? At point B, can I say tension will be acting like this? And can I say at point B, mg will be still acting downward only? Look at these two forces. At point B, tension is acting towards the center, and at point B, mg is also acting towards center. So what is net force towards center? TB plus mg, right? So what is the net force towards center? TB plus mg. What that should be? mv square by r. And at point B, what is the velocity we have? Root 3 ZL square by radius. If I calculate it, tension at B coming 3 mg minus mg, 2 mg. Do you know why did I ask you to calculate the difference? I could have asked you just tell me TA TB. Can you tell me why did I ask you to calculate TA minus TB magnitude? 8 minus 2, how much is that we are getting? Are we getting 6 mg? And you know, in a vertical circular motion, the difference in tension at bottommost point and topmost point, it is always 6 mg, irrespective of the initial velocity. But the condition is what? It should be completing the circular motion. Understood? If a particle completes the vertical circular motion, then difference in tension at the bottommost point and topmost point, the difference in tension is always equal to 6 mg. Understood? Even you could have calculated in the first example. I gave na here minimum velocity. We have calculated here the velocity. Here also if you calculate na tension at A and tension at B, the value will come different. Yes, the value will come different. Absolute value at A and B is different. But the difference in tension, that is always how much? 6 mg. Understood? Now tell me at point C. At point C, if I draw the free body diagram, what is the free body diagram will tell me at point C. At point C, if I draw the free body diagram, will I say mg force is acting like this and tension force is acting like this? And it will have some different velocity here. Hai na? Again, the velocity will keep on changing. Why? Because it's a non-uniform circular motion. So here, if I ask you, do you need to take component? Please tell me. Here also component is not needed. Why? Because forces are there. Tension is towards the center. Mg is perpendicular to that. Even if you take the component of mg, nothing will come towards center. Understood? So that's why no need to take the component. Can I say here Tc is the only force acting towards center? And that should be equal to mv square by r. But the problem in this equation is what? That I don't know the tension and I also don't know the v at point C. Matlab when particle reaches the point C, I don't know the velocity. So it means I need one more equation. From where I will get one more equation? Again, work energy theorem between what? A and C. So C velocity how much? I have to calculate. A velocity how much? Root 7 GL. Again tension work done 0. Gravity work done negative mg. What is the height difference between A and C? Look at the diagram. What is the height difference between A and C? This is the point C. This is the point A. Height difference is equal to radius, which is L given in the question. So if you calculate it, what are you getting the value of velocity at point C? So what is the velocity at point C? So 7 and this is 2. Root 5 GL we have. Just check it once.
Yes, sir.
What is the velocity at point C we are getting? So velocity at point C, we got it as, this is the VC I'm calculating. If I simplify it, velocity at point C is coming root 5 CL. Now that I can put it in the equation 1 and I can get the tension at C. M velocity means root, we are getting as the 5 mg is the tension in the string. But our question was not that. Our question was finding the tangential acceleration at point C. This is the object location at where? At point C. A question said, what is the centripetal acceleration there? What is the tangential acceleration? Do you know what is the centripetal acceleration? So at centripetal acceleration. So centripetal acceleration is actually v square by r. And centripetal force is mass into v square by r. We know now velocity at point C. We have calculated here. So how much is that calculated? 5cl square. Radius is L. We got the answer as what? 5g. Centripetal acceleration at that point is 5g. Okay. What direction? Direction is towards the center. What is tangential acceleration? Can you tell me by looking at the diagram? What is the tangential acceleration? Look at that. Is there any force in the tangent direction? Tangential acceleration, how it will come? Tangential acceleration will come with the help of tangential force. So what force is in the tangential direction? It's a mg, isn't it? That is along the tangent to the path, isn't it? This is how the path at this point, right? So tension is towards the center, mg is along the tangent. The tangential acceleration will come tangential force by mass. So actually, what is the tangential acceleration we have? Tangential acceleration is coming g, which direction? Downward direction. Understand the centripetal acceleration and tangential acceleration? They can also ask you, what is the net acceleration at that point? Can you tell me what will be net acceleration at that point? Under root of centripetal square and tangential square. So 25 plus 1, you can write it root 26z, you can say that. What else you can find out? Angle made by net acceleration with radial line. Angle made by net acceleration with uh, tangential line. Like that also can be asked. So if you look at the particle, is it the centripetal acceleration we got it? 5z. Is it the tangential acceleration we got it? Z. Is this my net acceleration which I have calculated? Root 26z. Which angle you want to find out? With radial line or tangential line? Let's say I want to calculate with the radial line. So can you tell me what is the tan theta will come? What is the angle it will be forming this theta? So am I getting tan theta equal to this component by this component? This component is z, the other component is 5z. Tan theta we are getting 1 by 5. See that? Please tell me everything about the circular motion. Do you understand? Please tell me. So one example we have taken where we try to understand everything about the circular motion, how to apply the work energy theorem, how to draw the free body diagram, take the component, right? Writing the equation. After that, finding the tension, tangential acceleration, centripetal acceleration. So these are all the things that can be asked in the question. Understood? Please tell me, clear up to this?
Yes, sir.
Yes, sir.
Sir.
Right. Now, just tell me if minimum velocity, how much is required for completing the circular motion? Root 5 GL, right? If someone will ask, sir, what will happen if I don't give root 5 GL? Let's say I only give the velocity root 4 GL. What will happen? So it will not complete the circular motion, that is for sure. Even not completing the circular motion, there are going to be two cases, okay? Incomplete vertical circular motion, okay? What happens in the incomplete vertical circular motion? Let me discuss with you. There are going to be two cases, okay? First case is, okay, there are going to be two situation of incomplete circular motion, okay? First one, velocity given at bottom point is less than root 5 GL, yes, but it is even less than what? It is even less than root 2 GL. I did not give even root 2 GL velocity, right? So in that situation, what will happen? Let's say at bottommost point, I gave the velocity under root of 1.5 GL. So what will happen? It will go some distance here, and after reaching this point, what will happen? It will come back. It will go to the other side, same angle, and it will keep on doing what kind of motion? So in that situation, the motion will be what? Pendulum. Motion will be what? Pendulum motion, or you can say that motion is going to be oscillatory one. If you give the velocity even less than root 2 GL, it's incomplete vertical circular motion. Understood? And the second case, what we have, we gave the velocity more than root 2 GL. Okay, we gave the velocity at bottom how much? We gave more than root 2 GL, but less than root 5 GL. Let's leave the equality both the side. Now what will happen? So in these kind of situation, this particle will go, it will cross this quadrant, this horizontal line, it will reach some point here, and after reaching this point, what will happen? Depending on what is the initial velocity we gave, what will happen? String will get slack. String will get what? Will get slack. And after slacking, what is going to do done by the particle? And after slacking means string will get loose. String will get what? Loose. And after slacking, particle will follow what path? Particle will follow a projectile motion. Follow a projectile motion onward. This is the two cases of insufficient velocity given. If the velocity is not sufficient enough to complete the circular motion, then the two cases will come depending on what is the velocity given at the bottommost point. If it is less than root 2 GL, it will just oscillate in its path. And if it is more than root 2 GL and less than root 5 GL, then it will reach a certain point, string gets slack at that point, and after that it will do the projectile motion. Okay. So when I will discuss with you the work energy theorem, work done calculation thing, I will again come back and I will discuss with you one or two question that how the string is getting slack, where it will get slack, and what kind of projectile motion it is going to follow once the string gets slack. So please tell me up to this part understood. The next thing we have to discuss is the circular motion now. Okay, please tell me clear. Sorry, work energy power. Okay, so next class we will start with the work energy power now. Please tell me clear.
Yes, sir.
So let's continue now in the next class with the work energy power. Okay, right, everyone?
Yes, sir.
Yes, sir.
Yes.
Okay. Let's meet it tomorrow. Tomorrow we will have the electromagnetism class, right? Current electricity we are discussing there. So let's continue with the current electricity now tomorrow. And again, next week onward, Monday onward, we will start with the work energy power. Okay.
Okay, sir.
Okay, sir. Thank you, sir.
Thank you so much. Let's meet it tomorrow.